Have you ever looked at some code and wondered, what on earth were they thinking? Why did you code it in that way? Why didn't you use library X and why didn't you use pattern Y? Well, I think I found a fix for that. So after a few excellent conversations with the community members over on Discord, and you can join for free as well, there's a link in the description down below, I have had this idea. So over the next 8 to 12 weeks, we're going to build an event ticket platform. This app is going to let event organizers create events and sell tickets. Attendees can then purchase those tickets, attend those events, and it will also handle the whole ticket QR code scanning thing at the event door. Now we do have a project brief and you can download that from Discord, but that's all we have. But fear not, because that's exactly what we want. So this build is going to be a bit more raw than my previous builds, as I'll be taking you through the build as I build it. Without the benefit of foresight, we'll likely have to rework some stuff, but that's the whole point, because you'll get to see my thought process play by play as it happens. The good, the bad, and the ugly. So here's the plan for this build. It's likely to change as we learn more about the domain, but here's today's understanding. We're going to start with some system design, so analysing the domain, the user personas, the user interface design, and some domain modelling. And that's what we're going to cover in this video. Next, we're going to design the REST API and the application's architecture. We'll then deal with project setup, including security. We'll then implement the domain, so actually write the code for the domain objects. And then we're going to deal with event creation and management. We can't deal with anything to do with tickets until we have that event. That's where we need to start. We're then going to deal with ticket sale and purchase. Now bear in mind, we're not going to be integrating with a real third-party payment system. No money's going to change hands here, but you can extend it to do so if you so wish. We'll then deal with ticket validation, so that's scanning the QR codes. And then we're going to deal with sales reporting. So taking all of the metrics from our application and then displaying them to our users. Mostly the organizers, I think. So that's the plan and we'll see how we get on. Now this is going to be completely focused on building. So there are going to be some prerequisites in order to get the most out of these videos. Because we are going to be time constrained, we can't really divert too much in order to deep dive the theory. So here are my recommendations. So the things that you need to know in order to get the most out of these videos. You need to be comfortable with the Java programming language. That's the first one. You also need to know Spring Boot, or at least be comfortable with Spring Boot. You'd also want to be comfortable with Spring Security. You don't need to know any of the advanced stuff, but just be able to configure Spring Security in a Spring Boot application. And I have some recommended things to know as well. The first one is to be comfortable with OAuth 2 and OpenID Connect. That's what we're going to be using most likely in order to handle our authentication and authorization. That's going to be our protocol of choice. And I also recommend to be comfortable with React and NPM. Again, you don't necessarily need to know how to build React applications. We're not going to be covering how to build React applications, but I am going to provide a React front end for you. So it would be beneficial to know how to run that and interact with that. So just a note on source code. Any source code that I write, I'm going to upload to Discord so you can download it too. And that will include the Spring Boot code and also the React application that I'll provide as well. Now, as I mentioned, we're not going to be covering how to build the React application in this series, but if you do want access to those videos, then I'll be posting very shortly to Discord on how you can get access to them. If you have any questions or if you do get stuck, then there is a whole community of developers on Discord and we'll do our best to help you out. Right, with that all covered, let's get started. In this lesson, we're really going to explore the project brief for our event ticketing platform with the aim of trying to understand the requirements of the system that we are to build. So here we are in Miro, and here we have our project brief for the event ticketing platform. You can download this project brief as a PDF from Discord, and it's exactly the same one that you'll see here. Now, if you haven't seen one of my project briefs before, it's broken up into various distinct parts. Usually it starts with a summary, so just a high-level description of the system that we're going to build. Then we have some definitions. So I like to define some terms that we're going to be using, in this case, event, ticket, and QR code. And then we have a set of user stories. Now each user story, we just zoom in a bit. So each user story has the as a, I want, so that format, and also a set of acceptance criteria. And together they describe the requirements of the system that we are to build. So in this case, we have create event. As an event organizer, I want to create and configure a new event with details like date, venue, ticket types, so that I can start selling tickets to attendees. And then we have a set of acceptance criteria, and these are statements that can either be true or false. So in case of the first one here, an organizer can input the event name, date, type, and venue. If we look at our built system, that statement is either true or false. And the idea is for all of these statements to eventually be true, and then we say that the user story is done, it's complete. In the case of this project brief, we have 1, 2, 3, 4 user stories. So let's start at the top and look to understand these user stories in more detail. Okay, in fact, let's just grab a highlighter. Okay, that should do us. So let's go through this. So a web-based platform for enabling users to create events, manage ticket sales, generate QR-coded tickets for attendees, streamlining the event management and ticket distribution process. So there's a few things that we can just learn from this. So for example, web-based platform says that we're going to be building some kind of web application. And then we mention here creating events, ticket sales, generating QR-coded tickets. Now that's another really interesting thing, QR-coded tickets. So we're going to have to use some sort of library to generate QR codes. And then streamlining the event management and ticket distribution process. So that's the value in building the system in the first place. So with that done, let's take a look at the definitions here. So we have the definition of an event. Where's that highlighter? So a planned gathering or occasion, specific date, time, and venue that requires ticketing for attendance management. So we'll come on to doing some domain analysis a bit later, but words like date, time, and venue, we'll want to take a look at those and track those a bit later. Now, for ticket, a digital or physical document that grants the holder access to an event, unique details for the event, and a unique QR code. So we're going to be generating digital tickets, which could then potentially be printed, which makes for the physical document, but each ticket has to have a unique QR code. And then we have the definition of a QR code, machine readable code, black and white squares, used to store ticket information and verify authenticity. So when the attendee gets to the event, has their ticket either digital on their phone or they've printed it out, the staff at the event are able to scan the QR code and then they can tell almost immediately whether or not that ticket is valid. So with that done, let's take a look at the user stories, of which we have 4 here. So creating an event. As an event organizer, I want to create and configure a new event with details like date, venue, and ticket types, so I can start selling tickets to attendees. So this user story is really about creating events in the first place, because we need this concept of events in the system in order to be able to sell tickets for events. Let's see if the acceptance criteria support that. So an organizer can input the name, date, time, and venue. They sound like properties on our event object. Organizer can set multiple ticket types. So that's interesting. So it's not just one type of ticket per event. There can be many different ones and they can have different prices. The organizer can specify the total available tickets per type. So there's a limited number of tickets per ticket type. And the event appears on the platform after creation. That makes sense. So that's creating an event. Let's go to purchasing an event ticket. So as an event goer, I want to purchase the correct ticket for an event. So correct ticket must be a reference to the ticket types up here so that I can attend and experience the event. So not only does the ticket get them in the door, but depending on the type of ticket they have will of course affect their experience. So let's take a look at the acceptance criteria. An event goer can search for events. So we'll need to have some sort of event search functionality in there. The event goer can browse and select different ticket types available each event, which I suppose should probably be each event. Let's put a T on the end there. There we go. Nobody will ever know. So event goer can browse and select different ticket types available for each event, and the event goer can purchase their chosen ticket type. So basically, somebody who wants to go to an event can search for tickets, look at the different types, and then they're able to purchase them. So create an event with certain tickets and certain ticket types, and this is somebody being able to purchase those ticket types. So purchasing an event ticket. Let's see what else we have here. So managing ticket sales. As an event organizer, I want to monitor and manage ticket sales so that I can track revenue and attendance. So dashboard displays sales metrics, organizer can view purchaser details, system prevents overselling of tickets, and the sales automatically stop at the specified end date. So this is being able to set limits on how many tickets can be sold and not being able to sell any more after that, and then being able to monitor it. Here it says displays sales metrics. So everything an event organizer would really want to know. It doesn't specify how we're going to display these metrics, but we can explore that when we get to that point. So that's managing the ticket sales. And then we have our last one here, which is validating tickets. So as an event staff member, I want to be able to scan attendee QR codes at entry so that I can verify ticket authenticity. So this is the part that we were discussing earlier. So basically somebody's bought a ticket, they've taken it to the event, and then the staff at the event are able to scan that QR code and tell whether or not that's a valid ticket. So staff can scan QR codes using their mobile device. So mobile device is a big one. So at the very least, we need to be able to view at least one page of our application on a mobile device, the one that displays the QR code. The system displays ticket validity status instantly. Instantly is always a funny word in project briefs. Usually there's an acceptable range. We don't have any definition of what instantly could mean here, so we're just going to, for the sake of this build, mean as fast as possible. We don't want an event staff member scanning a QR code and then having to wait several minutes in order to see whether or not the QR code is valid. So we'll bear that in mind when we design our system. The system prevents duplicate ticket use. So we need to keep track of when a ticket is used. So when we scan a QR code, that needs to be stored somewhere. So if somebody tries to reuse that ticket, they're prevented from being allowed into the event. And staff can manually input ticket numbers if the QR scan fails. So we need to put some form of ticket number on the ticket, and then having the ability to enter that ticket number on the same screen that we scan the QR code. Now, before we wrap up, I just want to draw your attention to something here. So we have 4 user stories: as an event organizer, as an event goer, as an event organizer, as an event staff member. So we have 4 high-level features here, but it seems like we also have 3 different types of user: an event organizer, which is these 2 user stories here, and then an event goer, which is this user story down here, and an event staff member. So we have 3 different types of user, 4 high-level features that we need to implement. And although there's a lot of detail not in here, as we start to design and implement our system, a lot of those details should become clearer. So for the moment, this should be all that we need. So in summary, the system serves 3 different user types. We have organizers, attendees, and staff members. The platform manages a complete event lifecycle from creation of the event right through to the ticket validation. And we have several features, including the event setup, the ticket sales, the monitoring of those ticket sales, and then entry validation, whether or not that ticket gets you into the event. In this module, we'll create an initial user interface design for our event ticket platform. We'll do this by looking to understand our users, their needs, and how they'll interact with our system. The module is structured as follows. We'll start by exploring the user personas. We'll then explore the user journeys, and then we'll design the user interface. So now for the learning objectives. So by the end of this module, you will be able to describe the application's user personas, describe the application's user journeys, and produce the first iteration of a user interface design. So with that covered, let's get started. So let's look at some user personas which model potential users of our system. Please note that the following user personas were generated by an LLM based on our project brief, so we can be confident that these people are fictional and the user personas are as unbiased as possible. So we've identified there are 3 different types of user. We have organizers, which organize the events. We have attendees, which attend to those events. And then we have staff that work at the event. So each of the user personas that we're going to see fit into one of these 3 categories. So first, let's take a look at the organizers. So first, we have our corporate event manager. So the primary goal of the corporate event manager is to represent the company's brand values through professional events, while tracking attendee analytics for business development. This user persona represents a data-driven decision maker valuing detailed analytics. Because of the focus on the company brand values, this user persona is brand conscious and needs customization options. And this user persona is focused on security and privacy for customer data handling. We then have our event planning professional. So the primary goal of the event planning professional is to efficiently manage multiple events with different ticket tiers. The main challenge here is managing multiple events while preventing overselling. As you would expect, this user persona is detail orientated with strong organizational skills. They are tech savvy but value intuitive interfaces, and they are time conscious and they appreciate automation. We then have our part-time event organizer. So the primary goal of this user persona is to create occasional events with minimal effort. The challenge is limited technical expertise and very limited time. They prefer simple guided interfaces with templates. They really value mobile accessibility, and they like to prioritize their customer-facing aesthetics. So now for attendees. We have our busy parent event attendee. So the primary goal here is to secure family-friendly event tickets in advance. The main challenge is coordinating multiple family members' tickets. They are a careful, advanced planner. They value clear venue information and accessibility details. And they really appreciate email confirmations and reminders. We then have our young event goer. Their primary goal is easy discovery and purchase of trendy event tickets. The challenge is finding affordable tickets and smooth validation, so getting into the venue smoothly with their ticket. They are digital native and they expect intuitive mobile experiences, and they are price sensitive but they value unique experiences. And they prefer last minute purchases and digital tickets. We now have our corporate networking attendee. So the primary goal here is efficient registration for professional events. The challenge is they need detailed receipts for expense reporting. They value a streamlined checkout process. And as you would expect, they require corporate expense documentation. And their ask is that they want calendar integration and professional reminders. Now for staff. We have our event staff coordinator. So their primary goal is to manage entry validation for large events. The challenge is they need consistent validation across multiple entry points. They're process orientated and focus on security and accuracy. They need reliable, simple tools for their team, and they value speed and reliability over complex features. Then we have our entry-level event staff. Their primary goal is quick and accurate ticket validation. The challenge is handling high-pressure entry with minimal training, and they have limited technical expertise requiring an intuitive interface. And it may be their first job or a temporary position, and they need clear instructions and clear error messages. So in summary, we've explored the user personas representing organisers, attendees, and staff. These user personas will influence how the system is designed and implemented. So let's now explore some user journeys, how our user personas may interact with our application. So here we are back in Miro, and I'm going to take you through the user journeys of the 3 types of user that are going to use our system. We have organizer, attendees, and event staff down the bottom there. I've used a bit of imagination with these user journeys just to try and figure out how these different types of user would use the system. So this is by no means perfect. However, it should inform how we then go on to design our user interface, if only a little bit. So let's take a look through what we have here, starting with the organizer. Now we have several different types of organizer. We've already taken a look at their user profiles. So here's what I think they all more or less have in common. So they start by logging into the platform, creating a new event. There's all sorts of different types of event. We've looked through each of the user profiles and seen there's a whole wide range of event. Now, I imagine this particular step might include selecting an event template, but it remains to be seen. So after we've created a new event, we can then configure the types of ticket for that event. We've decided that there's going to be several types of ticket for that event, possibly. So we'll need to configure that maybe in the same step, maybe as a separate step, but it's explicit here as a separate step. And then we'll need to set pricing. Now, we haven't really delved into pricing too much other than saying that different ticket types can have different pricing, but I imagine this as a separate step in the user journey. So we have set pricing there. Then there's a step of reviewing the event details before it's then published. And I've called this event creation. So after the event is published, that's typically when attendees would then go and purchase tickets, but we'll get to that in a moment. We then have sales management. So the user personas mention wanting to track sales. So there's going to be monitoring of the sales dashboard, tracking ticket inventory, because of course events can hold only so many people. And then I've put in adjust ticket pricing, assuming that pricing is going to be variable based on supply and demand of tickets. We then have event preparation, and this is perhaps where the most imagination is being used. The organizer is present on the day. Perhaps they brief the staff on the check-in process. Maybe they test the scanning equipment themselves. Maybe they're not involved in this process whatsoever. But there's some prep just before the big event day. And then we have the event day, where they're going to monitor the entry analytics, see how many people, how many attendees have attended the event. And of course, there's going to be handling of ticket problems, if and when they occur. And after the event day, there's going to be the final reports. Each of the user personas mentioned reporting in some way. So there's going to be a step where we take a look at all of the numbers from the event day. So that is the organizer. Let's take a look at what I imagine the attendees' interaction to be. So they first have this discovery phase where they're browsing the events, they're seeing what's available. So once an event's been found, you'll then want to check the ticket prices. Because a single event can have multiple different tickets or with different prices, you may share the event with your friends. or in the case of the corporate event attendee, colleagues, or in the case of the busy parent attendee with family members. And then we have coordinating group attendance, so who can actually go. And then we have selecting the ticket quantity, how many tickets we to purchase. And then we have reviewing the fees and the total, completing payment. I've said mobile payment here because they're all mobile first users. And then receiving digital tickets with the option to print them off. The event preparation in this stage is storing the tickets in the digital wallet, sharing tickets with friends, getting that event reminder. And then on the event day, it's arriving at the venue, quick scanning the QR code, entering the event, and then the post-event, in the case of the attendee, is usually sharing on social media, maybe following the venue for future events. And then we have the event staff. Now, I've positioned this more to the right in the sense that their involvement doesn't begin typically until just before the event day. So we have the event preparation, so accessing the event details, seeing the different types of ticket available, seeing the rules of each of the tickets. Maybe in the case of the coordinator, briefing the staff on the procedures. And then on the event day, we've got testing the scanning equipment, making sure the system actually works before we actually go to use it. We then have positioning the staff members at the different entry points, maybe verifying radio communications. And then we get to scanning the attendee tickets, handling any ticket issues. And then after the event, we have the debrief, which was mentioned in the event coordinator persona. So this might seem a bit whimsical, and I suppose it is in a way. However, what it does, at least from a user interface point of view, is identify the different stages. So we know that there's going to be, in the case of the attendee, some discovery. So there may be a page in order to search for events, which there almost certainly will be. Purchasing, there's going to be a purchase page. Event preparation, this might be different types of requirements, storing in a digital wallet, sharing the tickets with friends. And the same can be said for the rest of the user journey and the different user journeys that we have. So this is just a high level overview. Hopefully it's been useful, but then we can take this information going in to our user interface design. So in summary, we've explored the user journeys for organizers, attendees, and staff. The user journeys offer insight into how different users may interact with the system. And the user journeys will influence how the system is designed and implemented. So let's now take a look at the initial user interface designs. So this time we are in Figma, and I'm going to take you through how I've imagined this user interface to be. Now, this is, I suppose, like a wireframe in a lot of ways. Just instead of lines, I've used shapes. There's a lot of detail not in here, but we'll fill it in as we go further through the process. So I've tried to bear a few things in mind when I've designed this. I've tried to bear in mind everything that we've learned from the individual user personas. I've also tried to bear in mind the user journeys and how we've imagined them to be. And you'll see the stages in the user journey should match up to the different pages that we see here. So let's explore what we have. So I've got some different flows, if you will. And the first flow that we have is applicable to all of our user personas. And that's creating an account. And I've just got a simple page for this, create an account, add maybe a username and password, click on sign up. It'll give you a confirmation page to say check your email, because we'll need a valid email. And then that will give them the ability to log in with their account. With this, I've gone for complete simplicity. It's got the bare minimum number of moving parts and it should allow the user to log in. Now we can choose different views for how they log in and what they see depending on the user type, but ultimately the login will be similar if not identical. So let's now explore our organizers. So we have our organizers up here. So I imagine the organizers have a different landing page than everybody else. They may have a page geared towards business to business. So it may be describing the benefits of the system rather than describing all of the events that are available. So we have here, create, manage and sell event tickets with ease, maybe a big picture on the right-hand side here. Maybe it goes down to testimonials, etc. So a user can either hit this landing page, log in, hit create event, sign up, but I've included this just for completeness. So let's assume that one of our organizers has signed up, logged in, and they're able to go to their dashboard where they can create a new event. Now I imagine this being a form where the user can input all of the information that they need to create an event. So that's going to be the venue details, that's going to be the pricing, That's going to be the different ticket types, etc. It's all going to be on this form, which is at the moment just represented by these different boxes. But once we model our domain a little bit further, we should understand exactly all of the different boxes, inputs that we need to put on this page. And that will give us a next round of refinement for a design. So creating a new event. So let's assume we created several events and they've been published and they're out there. So there's going to be a dashboard. And the dashboard is going to have several buttons on the left-hand side here, which haven't been represented, but we'll see the pages that they link to in just one moment. But I think on hitting the dashboard, there should be some sort of visual representation, some sort of graph, which gives fast feedback, fast information on exactly how their events are doing. In the case of organizers that handle multiple events, I imagine multiple different lines to be on this graph in some way. Maybe it's ticket sales that we display on here. So hitting the dashboard, we just get some fast feedback on how everything is going. And then if we click on a button on the side here, perhaps we want more information on ticket sales. And then we can go to the ticket sales page and we can view the individual ticket sales. Maybe there'll be some sort of filtering on here. Maybe there'll be some totals and numbers. I've just represented these boxes, which will allow us to basically display the information for each sale, when it happens, how much was sold for, what ticket type it was. I imagine it all being in these individual boxes. Maybe with pagination, maybe with filtering. So that's one page on our dashboard. I also imagine there being an Your Events or event management page. So all of the events that we've created so far, they can be listed here. Now, how these two pages, the ticket sales and the event page sales, interact, I'm not too clear on. And this would be something I'd ask a stakeholder. Would you want to see all of the ticket sales for all of your events listed together? Or would you want to go to your events, click on the event, and then see the ticket sales? So we'll make a decision on that, but largely the pages would remain visually the same. And then we have your ticket types. Again, this would be a great question to ask. Would you reuse ticket types across multiple events? Or would you have different ticket types but only used in specific events? But again, the listing of them here with all the details, possibly giving the user ability to edit them. And then we have a reporting page. So this is where the user can go in order to select each of the different reports. There's going to be some reports which are event specific, and in which case we may link to them on the Your Events page. However, there's going to be reports which are across the board for all of the activity in the account. And I suppose we'd want to see those in a dedicated place. So that's what this Your Reports page is. Again, this design isn't set in stone and it will change, but this is how I'm picturing it at the moment going in. So that's our organizers. So let's now take a look at our attendees. So if we go to the top here, now I imagine the attendees are going to see a landing page which is different to what our organizers see, because they're here for a very different reason. They want to find tickets really quickly, really simply. So I have a page here which looks pretty similar to the restaurant review platform that we built. However, it serves much the same purpose really, which is a user can go search for a ticket. They can maybe filter by ticket type, maybe price if they're budget conscious. Each of these filters here, they can then sort, and there'll be some form of pagination. But ultimately, we'll represent each of these different events with a card with all the information that they'd want to see. On clicking the card, they would then go to the event details page. So there may be an image of the event, there may be a carousel, something like that, where you can see multiple images. There'll be lots of information on the event, and maybe we can use some icons to represent the different facilities available at the venue, which is something that's been expressed as information that people want in the user personas. I then imagine there being the different ticket types that are available for the event. Again, nothing super fancy on this page, just nice and simple information, the different ticket types available. When you click on them, it will display information on that particular ticket type, including the price, the rules, what it gets you, and then you can choose to buy the ticket. On buying the ticket, you then go to the purchase ticket page where you enter your payment details, click on purchase. Now this is typically where you would integrate with a third-party payment system. We're not going to do that. However, you can completely replace this page once it's built with a third-party payment system if you so choose. However, we'll not cover it in this build. So we'll purchase tickets on this page, click on purchase. Thank you for your purchase. You get a confirmation. That would then send an email. Again, we'll not integrate with an email sending, but this is the event where you'd send that email, that notification. and then they can choose to go back to the search page in this case for a attendee. And I imagine that the attendee would also want a dashboard where they can see all their tickets for all their events, especially in the case of, say, the young event goer persona, where they're going to 2 or 3 events a week. They'd want them all listed out so they're easily available. Log in, click, and then you get details on the event. And then there'd also be a link to be able to show the QR code. And I've also put the kind of number for manual entering on here as well. And then that will give the ability for scanning on the event day. Now there's some details which isn't displayed here. Now each of these pages I imagine working on mobile. They collapse down fairly simply in most cases. There's also the digital wallet aspect. Now the link between the digital wallet and say this page isn't entirely clear. Now, I imagine there's probably going to be some hoops to jump through in order to interact with a digital wallet. So we may have to not go as far as that, but there will be this page that the user can display in order to scan their QR code. So that's the basic flow that I imagine for our event goers, so for our attendees. And then the last user type, which is our staff. So they log in. I've only provided a mobile view, or perhaps a tablet view in the case of our staff coordinator, but it would be much the same. All of the cards for the events that are live for those particular staff members, assuming that there's more than one on the same day. They'd then click through and it would stay on that page or this page that you're seeing now for the entire time. So the user can scan the QR code using this big button here. It would then open up the camera. They can then scan the QR code and then they'll get immediate visual feedback whether or not the QR code is valid or not valid. They also have the ability to enter the code manually. That will then bring up the keyboard. They can enter that in. But ultimately, this page is very simple, which is scan QR code. Is it valid or not? Move on to the next one. I've put the Browse Events button up the top, so that will bring you back to this page, just in case somebody misclicks. But I didn't want somebody to accidentally hit this button, so I've not put it down the bottom with the rest. And these two are actually very spaced out. You'd have to go all the way up to the top of the page and then click on Browse Events, which if you're holding a phone would mean using your other hand to click the top of the phone. So very unlikely to happen accidentally. So this is the user interface that I've imagined for the moment, and we'll refine this further in the coming lessons. So in summary, we've designed the first iteration of the user interface. The designs have been influenced by user stories, personas, and journeys. So let's recall what we've achieved in the user interface design module. In user personas summary, we explored the user personas representing organizers, attendees, and staff. These user personas will influence how the system is designed. In user journey, we explored the user journeys for organizers, attendees, and staff. And the user journeys offer insight into how different users may interact with the system. The user journeys will influence how the system is designed and implemented. In UI design, we designed the first iteration of the user interface, and the designs have been influenced by the user stories, personas, and journeys. Hi there, quick interruption. If you do have any questions about what you've seen, or if you do get stuck at any point, then feel free to reach out to the community on Discord. You can join for free. There is a link in the description below. In this module, we'll create a class diagram that represents the application's domain, and this should give us all the information that we need to design the application's REST API. So this module is structured as follows. We'll start by establishing the domain model. We'll then add cardinality information to the class diagram. We'll then add data type information to the class diagram. And then we'll define each variable as either required or optional on the class diagram. So now for the learning objectives. So by the end of this module, you'll be able to describe the domain represented by the application's domain diagram. Add cardinality information to the application's class diagram. Add data type information to the application's class diagram. And finally, add required and optional information to the application's class diagram. So with this covered, let's get started. So let's take a look at the high-level summary of the domain model. So after spending a bit of time analysing the project brief, using a variation on the noun-verb analysis technique, I produced the following domain diagram. So we can see represented here the user, the different types of user, organiser, staff, attendee. We also have the event, which offers ticket types. Those ticket types have tickets associated with them, which also have QR codes associated with each ticket. A ticket can be validated and a ticket can be sold. If you prefer, there's this mermaid.js diagram as well, representing exactly the same thing, slightly less colourful, perhaps a bit more formal. So let's now explore the domain objects. So let's start with the event class. It has a unique identifier, that's its ID, and it contains event details like the name, the date of the event, the time the event starts. It includes the venue location. And we also have a sales end date, and that's the very last date and time that tickets are available for that event. So now we have our ticket type class, which is different from a ticket. So the ticket type has a unique ID for identification. We have a name on the ticket type, such as VIP or standard. We also have a price for that ticket type, and we also have a total available property, and that's a number and defines the total number of tickets available of that ticket type. And now the ticket class has a unique ID. It also has a status, and that will allow us to have the status of cancelled perhaps if we do cancel a ticket. We also have a created date time, which records the date and time the ticket was purchased. We only create tickets when a user purchases a particular ticket type. Then we have our QR code, has a unique ID, and we have this generated date time, which stores the date and time it was created. And we also have a status. So if we did want to invalidate a QR code, we would do that by setting the status to invalid and generating a new one. We then have our user class, has a unique ID, and it stores basic information like the user's name and email address. And I've said here extended, but actually we haven't really formalized what that relationship looks like, but we have organizer, attendee, and staff, which are types of user. We then have our ticket validation class. That contains a unique ID, and it has a validation time. So that's the time that that particular ticket was validated, which may represent the time that a particular person tried to get into an event with that ticket. We also track the validation method used. Was it validated via a QR code, or was that ticket number manually entered? We also store the status of the validation result. Was the ticket valid, or was it not? So in summary, events can have multiple ticket types, each with their own pricing and availability. Users can act as organisers, event goers, and staff. Tickets include QR codes for validation at event entry. And ticket validation ensures proper event access control. So let's now add cardinality information to our class diagram. So here we are back in Miro. At this point, we've got a domain diagram. We have analysed some user personas. We've taken a look at some user journeys, and we've created our very first initial user interface design. Now we're going to get a bit more granular. On the assumption that our application is going to expose a REST API, we're going to evolve our domain diagram into a full-blown class diagram, and that will then allow us to design the REST API. So here is our domain diagram. We're now going to evolve this into a class diagram. So the process that we're going to follow is going to look a little bit like this. So the first step that we're going to follow is add cardinality to our diagram. If you're not sure what that means, don't worry, because we'll cover that in a moment. We're then going to add data types. So we've got properties identified, ID, name, date. What types are we going to use for those? And then 3, we're going to add the required or optional clarification on each of our properties. Which ones do we actually need? Which ones are truly optional? Let's just move that over here a little bit. And there are some other steps that we could follow, but for our activity today, we're just going to do these things here. This should give us enough information in order to then design our REST API. So let's start at the top. So we're going to need a text block for this. I'll put a star in there for the moment. Okay, so let's now move on to cardinality. So with cardinality, we're basically adding more information on the relationship. Relationship comes in 2 parts. We have a user here and we have a ticket. We're going to specify, in the case of the user, can a user have 1 ticket or multiple? And then the inverse. For each ticket, is there 1 user associated with it, or no users, or many users? We can define that all here. Now, where I say class diagram, we've already started using sticky notes in Miro, so we're going to carry that on, and then I'll formalize it in mermaid.js. So let's get started and see how we get on. So let's start with this user ticket relationship. So a user purchases a ticket. So for each user, how many tickets do they purchase? Well, they don't purchase 0 tickets because there wouldn't be a purchase at all. They can purchase 1 ticket or they can purchase many. So we're going to say 1, dot dot star. Let's make that a bit smaller and we'll put that there. And what that means is for each user, they can purchase one or multiple tickets. However, of course, there is the case where the user hasn't purchased any tickets. So actually it is 0 to many tickets. You don't need to have purchased a ticket in order to create an account, I suppose is the assumption, especially when you consider that organisers and staff may not purchase a ticket and they are users. So that's much better. Let's just make that a bit smaller. There we go. So in the case of the ticket, is a ticket always associated with a user? Now, this is a good question. Do we only create tickets when a user purchases them? I think yes. Let's make that assumption to begin with. So let's say 1. So what this means is in the system, a user can have 0 tickets associated with them. They could have never purchased a ticket. They just simply have an account. Or they could have purchased many tickets, 1 or more. The inverse is to say that for a ticket to exist in the system, they need to be associated with a user. So I think we only create a ticket object when there's a purchase. And then we generate the QR code, and then that ticket is associated with the user and they can see it on their dashboard. Rather than having a whole bunch of ticket objects sat there that we then assign after the fact. Let's make that assumption and see how we get on with that. So that's our user-ticket relationship. Now, in the case of the ticket QR code relationship, how's that going to work? Let's take a copy here. A ticket will have, I'm going to say, 1 or more QR codes. And here's my rationale, here's my reasoning for this. When a ticket is created, we'll also create a QR code to be associated with that ticket. However, we may want to invalidate the QR code for any reason whatsoever. So therefore, we change the status of the invalid QR code to say invalid, and then we generate a new QR code and then assign that to the ticket. Now, in the case of the QR code, for a QR code to exist, does it always need to be associated with a ticket? I think yes, it does. Otherwise, we just have a whole bunch of QR codes without any context. And in considering a QR code would include the ticket information, it will almost certainly be associated with that ticket. Okay, let's move on. So this is just the initial thinking, by the way. It almost certainly will be incorrect at some point and we'll need to correct it. But this gets us moving. So let's now take a look at the ticket and ticket sale relationship. So when a ticket is sold, we get this ticket sale object, which we've separated out because we could have this information on the ticket, I suppose, but we've separated it out with the idea that if it's its own thing, we could potentially then collect them together for reports. So let's take a look at this ticket sale relationship. So a ticket can only be sold once. So we're going to say 0.1. Now I'm still a bit unsure on whether or not this ticket sale deserves its own object. It would have benefits when it comes to reporting, I think, because we can just interrogate a collection of ticket sales rather than the ticket themselves. So it would be dedicated for the purpose. But again, it's a bit abstract at the moment, so we'll have to see how it goes. But that's to say a ticket can either be, but that's it, isn't it? We've decided that we can only have a ticket. Yes. So a ticket must be associated with the user because a ticket is only created once it's sold. So I think what I'm going to do then actually is we're going to take the information from ticket sale, and even though the ticket sale is still an event that we need to be aware of, we might send notifications at that point, I'm going to add the information from ticket sale to ticket and then delete that object. Because actually I think it may very well be the same thing. If we're only creating a ticket once it's sold, then it will almost certainly have a purchase date time, a status. And I suppose if we did invalidate that ticket for whatever reason, we could then assign a new ticket to the user. That may be the way that we deal with it. So what about ticket and ticket validation? Now, whereas a ticket and a ticket sale, there'd only be one ticket sale per ticket because you can only sell a ticket once. I suppose there's a concept of resale, but we'll not support that in the system. So you can only support a ticket once. So it made sense to combine ticket and ticket sale. But I don't think that same argument is valid in the case of ticket validation because a ticket could potentially be validated multiple times. It could be a simple mistake. Perhaps the device scans the QR code twice. Or it could be something more malicious, like a ticket is copied and several people attempt to get into an event using the same ticket. In either case, I think we should store ticket validation separately, because it's going to be this case where a ticket can have 0 to many ticket validations, and a ticket validation must always be associated with a ticket. Okay, so now ticket and ticket type. In fact, I wonder, because this ticket type relationship, at least in my mind, is a bit unclear. So I'm going to come back to this and instead go up to the organizer-manage relationship here. So we have an event, and an organizer manages an event. What would the cardinality be for that? So I'm going to say an organizer can manage 0 to many events. It may be the case that it's a brand new account, doesn't have any events associated with it yet. Or it could be our corporate event manager that deals with hundreds perhaps. For each event to exist, does it need to be associated with an organizer? I think it does. So we'll do it that way. So an organizer can have 0 or more events, but an event always has one organizer. In the case of a team setup, because I think that occurred in the customer personas a few times, I think there'll still need to be a nominated individual that owns it. Maybe the team sharing, if that feature ever gets implemented, will then be a secondary mechanism. So the staff member works at an event. So I think in the case of and we'll probably need to separate these out just so it's obvious which line's which. So the staff member works at an event. I think the staff member works at no events up to many. They can only work at one at any given time, but maybe they're working at multiple events in one day, for example, and therefore they're associated with many at the beginning of the day, is my thinking. So a staff member can be associated with 0 or many events. An event can be associated with 0 or many staff members. If the event's just created, I don't think it's going to have any staff members associated with it. That may only happen on the event day. So I think that's a valid state to be in. Now for attendees. So an attendee can have, and we'll put this, it might get a bit unclear. So let's move that on that side and move that on that side. So an attendee can have 0 or more events. So let's say somebody's just created their account. They're not going to have any events yet. However, they may have many events if they've attended or they're about to attend many events. So the attendee to event relationship is 0 to many. In the case of the event to attendee, I think it's probably the same. So we'll put that here to say that an event can have no attendees associated with them, so 0. It might be a brand new event, or it could have many attendees associated with it. Okay, we'll not put any cardinality on this relationship with staff, user, organizer, user, and attendee user, because I think this may be a subclass role relationship. It certainly is a relationship. So we'll not put any cardinality on that. So that leaves us determining the relationship between event, ticket type, next. So each event, I think, will have 0 or more ticket types. I think for an event to be published, it will definitely need at least one ticket type. However, when an event's first created, I think it's valid for an event to exist in the system without any ticket types associated with it. In the case of a ticket type, this kind of comes back to something I was wondering earlier, which is, can we just create ticket types in the system and share them between different events? Or is ticket types specific to the event? And I think I'm going to make a design decision to say that the ticket type is specific to the event. So that's to say that a ticket type is only associated with one event at any given time. So now ticket type and ticket. So the way that I'm picturing this in my mind is that an event can have multiple ticket types. Each ticket type has a total available count of tickets of that type that can be sold, like an inventory count, if you will. Every time there's a purchase, we create a ticket, we generate a QR code for that ticket, and then that ticket is associated with the user, which actually means, thinking about it, the created date time and the purchase date time of a ticket is going to be the same thing. But what about the cardinality? So each ticket is only ever going to be associated with one ticket type. And in order for a ticket to be created, there must be an existing ticket type. A ticket type, I think, can have 0 or more tickets. In the case of a brand new event that's just been published, I don't think there's going to be any tickets associated with that, 0. But in an event that's just before event day with loads of tickets sold, that's going to be a 0 to many association. We've been talking a lot about publishing events, and I've come to realize that we don't actually have a status on event to say that an event can be published. So let's add status while we're here. Okay, I believe that's all of the cardinality added to our domain diagram. So that's one on the list done. Next, let's add some data types. So in summary, we've added cardinality information to the application's class diagram. So let's now add data types to our application's class diagram, using the phrase class diagram loosely because we are using sticky notes here, but we will formalize this. So in order to add data types, we're going to go through our individual domain objects and then determine the data type of the individual properties. Now, the notation I'm going to use for this is the colon notation, which is a little different from what we'd see in Java, but I think it will make it more readable, at least for the time being. We can always change it when we formalize it in Mermaid.js. So let's start with the user. So a user can have an ID. Now, what type of ID can a user have? I think for maximum scalability, we should probably go with a UUID. So an ID is a UUID. A name, let's just go with a string for a name. An email is going to be a string. See this colon notation rather than put string in front. So that's our data types for user. Let's carry on through. So for a ticket, I think having an ID as a UUID makes perfect sense. Now for status, the status of a ticket, I think this should be a ticket status enum. There should be some clearly defined statuses for our ticket. Cancelled, active, I think they should be initial ones. I'm not going to represent ticket status here, but just know that we'll use an enum for this. Maybe we just rename it enum to make it obvious. Okay, created date time, that's going to be a local date time. So we're actually going to use the Java class in this particular case in order to be specific. In fact, for consistency, perhaps we should do that up here. There we go. In actual fact, a UUID may also be represented as a string type, but we'll leave it as UUID in order to communicate that. And we've got status twice for ticket, so let's remove that one. Let's see if we can just make that all fit. Not easily. Okay. So that's the types for ticket. What about QR code? I think QR code is going to need a UID type as well for consistency. Generated date time is going to be a local date time. Status will have another enum, QR code status enum, which I think might be very similar. So active, cancelled, invalidated, something like that. Okay. What about our ticket validation? It's going to need a UID as a type. We'll use that consistently now. Ticket validation, that's going to need a status enum, I think. So ticket validation enum. And that'll be whether or not the ticket passed validation or failed validation. Or maybe there's a third status where the validation itself was removed or invalidated. I think it gets a bit meta at that point. But basically that will describe whether or not the ticket validation was a pass or a success. Validation date time, we'll use local date time for this. Validation method, again, that should probably be ticket validation method enum. Clearly defined choices for this one. It's either a QR code scan or it's a manual entry. And they're the two options that we know about so far. So that is a good use case for an enumeration. So what else do we have over here? So ticket type. At this point, we know that's a UUID. The name of the ticket is almost certainly going to be a string. Total available. We'll have to think about the proper numeric type for this, but I think an integer is probably going to cover most cases. We might have to go larger to a long, maybe a big int. We'll have to see. For price, how are we going to represent price? I think there's a few different ways of doing this, but we'll assume that it's a double for the time being, I think. Okay. So that's done, that's done, that's done, that's done. Event. Let's do event next. So ID is going to be a UID. Name, string. Date, local date time. Oh, we have a separate date and time. Maybe we should, now this is a good point. I think what might be a better way to do things if we say start date and then, or start date time, or maybe just simply start and then end, like that. And then we have clearly defined start and end times for the event. And then from that, we can extrapolate things like the duration of the event, the venue. Now, the more I read into this, I'm starting to think a venue is probably its own object. But for this first iteration of the system, we'll just do a string, a description of the venue and its various different facilities and amenities. Sales end date, local date time. Maybe we should also have a sales start date. You may want to schedule a ticket to go live at a certain time. So let's add that right there. And then we have a status for an event. So I think there's going to be an event status enum. Again, we can determine what sort of statuses an event can be in. I think draft, published, cancelled, but we can confirm that when we come to implement it, as long as we know we're using that enum. And then we have our organizer, staff, and attendee, which are types of users, but are almost certainly going to have information associated with them. In the case of the staff member, they may be assigned a certain entry point, which is a concept that we've not yet represented in this diagram. But as the entry point is also event specific, I think rather than go down that rabbit hole, we'll just leave it for the time being. So organizer, staff, attendee. Okay, so looking at these objects, it looks like they all have types at this point. So we've done number 2, we've added our data types. So in summary, we've added data type information to the application's class diagram. So let's now define whether or not a property is required or optional on our application's class diagram. So let's now look to capture the required and the optional instance variables on our classes. We're going to represent a required instance variable with an asterisk and then an optional with a question mark. And I'm going to put this on the type. So in the case of the ID, we'll certainly need an ID. So that's an asterisk. A name, that's going to be required for a user, as is an email. For the ticket, we'll certainly need an ID. We're going to need to know the status. A ticket should always have a created local date time. In the case of a QR code, we're always going to need an ID. We're always going to need a generated date time, which for consistency perhaps should be created date time. And we're always going to need to know the status of that QR code. So another required. For ticket validation, we're always going to need an ID. We're always going to need to know the status of that validation. Otherwise, it's not going to exist. Validation date time, that's required, as is the validation method. Over on the ticket type, we're always going to need to know the ID. We're always going to have a name for a ticket type, a friendly name. Total available. Now this is interesting. Do we need a total number of ticket types available? I'm actually going to mark this as optional. My thinking behind this is there may be an edge case somewhere whereby we can sell unlimited number of tickets for an event. And I'm thinking maybe like an online event where space isn't an issue. So in the case that tickets are unlimited, rather than put in a really high number here, let's just make it null and never have a limit. So I'm going to make that optional. Price. I think even in the case that it's free, we should specify 0. So let's make that a required field. So let's go up to event now. Asterisk. We need an ID. We need a name. For an event, do we need a start and end time? Are we ever going to have an event without a start and end time? I don't think that we are. So we're going to go with an asterisk saying that it is required. Venue. Yes, we're going to need to have a venue, a sales start date and a sales end date. I think we're going to make this optional. I think in order to be published, which is the status, which is required, we're going to need to specify a start and end date for sales. But if we've just created an event and it's in draft status, we don't yet know when it's going live, I think having sales start and end date as optional parameters makes more sense. And looking at things, I think that is everything marked up. So I think with that, we've completed step 3, which is we've added required and optional annotations to each of our instance variables. So the next step for me now is I'm going to formalize this into a Mermaid.js diagram, but next we're going to design our REST API. So in summary, we've added optional required information to the application's class diagram. So let's now recall what we've achieved in the domain modeling module. Into main model summary, we established that events can have multiple ticket types, each with their own pricing and availability. Users can act as organisers, event goers, and staff. Tickets include QR codes for validation at event entry. Ticket validation ensures proper event access control. In domain modelling, cardinality. We added cardinality information to the application's class diagram. In data modelling, data types. We added data type information to the application's class diagram. In data modelling, required and optional. We added optional and required information to the application's class diagram. And in data modelling, required and optional, we added optional required information to the application's class diagram. And with that, we now have a class diagram to work from. Now, if you look up here, you should see the next video in the series. And if you don't see it, it means it's not out yet. So be sure to subscribe and hit the bell to be notified when it does come out. And in the meantime, the algorithm thinks this is useful, so you should probably check it out. I'll see you over there.